Assalamualaikum warahmatullahi wabarakatuh, and a very good day to the panel of SSS Associate Professor Technologist Dr. Ibrahim and Technologist Dr. Ahmad Rizal. I am Ibrahim bin JAMALUDIN TE22015, and today I'm presenting on my final year project titled Critical Barriers for Integration of Building Information Modeling BIM for Sustainable Lifecycle Operation and Maintenance of Municipal Waste Infrastructure. Okay, this study supports Malaysia's transformation towards IR 4.0, the Smart City Blueprint, and the Sustainability Development Goals. Okay, as municipal waste infrastructure forms the backbone of urban sustainability, enabling the safe and systematic collection, treatment, and disposal of solid waste. Okay, as urbanization in Malaysia reached 62.7% in 2023, as stated by the Statista, the need for resilient and data-driven infrastructure has become critical. For example, in Selangor, we have key facilities such as the Semenyih Waste-to-Energy Plant, the Shah Alam Transfer Station, and also the Cyberjaya Recycling Station, all of which require long-term maintenance and monitoring. Yet, many of these still rely on manual documentation and reactive maintenance, which hinders sustainability, increase long-term costs, and also limits regulatory compliance. Okay, the Construction Industry Development Board, or CIDB, has mandated BIM usage for projects above 10 million, effective on August 2025. So, according to Deputy Works Minister Ahmad Maslan, BIM could prevent tragedies like Jalan Masjid India sinkhole by improving underground asset tracking. Alright, so globally, BIM transform not just how we design and build, but how we maintain infrastructure over its life cycle. Many Dugan and Fisher in 2021 stated that civil infrastructure digitalization enhanced coordination, control, cost control, and also life cycle decision making. Yet, Malaysia still lags behind in adopting BIM for post-construction asset management. Okay, let's look into the problem statement in this project. There are four key problems that justify this study. First, BIM usage in Malaysia is still mostly limited to design and construction. Second, operation and maintenance of municipal waste facility is complex and data intensive, demanding real-time system. Third, there are significant technical, financial, and organizational barriers to BIM integration. And lastly, there is a research gap in applying BIM to sustainable maintenance of municipal infrastructure. Okay, this study seeks to answer three research questions. First, for what are the current practice and digital readiness of waste infrastructure maintenance? Okay, secondly, what are the key barriers to BIM adoption in operation and management? And third, how can BIM be integrated to support sustainability, circular economy, and national agendas? Okay. From this, the research objectives are: one, to investigate the current operation and management practice, and then also to identify barriers to BIM adoption, and lastly is to develop a strategic BIM enabled framework for sustainable maintenance. Okay, let's walk through to some of the scope of this the study, that is where I limited it to public sector municipal waste facilities such as landfills, transfer station, recycling station, and also waste to energy plant. It focuses solely on the operation and maintenance phase within Malaysia's local and semi-urban context. Technologically, it emphasizes BIM application like asset tracking, predictive maintenance, and also digital inspection. Alright, so the stakeholders include BIM consultants, municipal engineers, and facility operators, and I exclude architectures and construction phase personnel. So thematic area include digital readiness, BIM barriers, and also sustainability in infrastructure maintenance. Okay, let's go to the major contribution of this study, which is this study modernized waste facility maintenance by introducing digital inspection and planning tools. Okay, second, it also support Malaysia Industrial Revolution 4.0, Smart City Initiative, and also the CIDB BIM, or Building Information Modeling Roadmap. And also, it addresses a critical research gap in BIM integration at the operation and maintenance stage for waste facility. And for the fourth, it helped engineers and policy makers make informed decisions by identifying the core barriers, And lastly, it promotes circular sustainable infrastructure aligned with SDG 11 and SDG 12. Okay, let's have a look on the literature review that is structured into 5 sections, which is the first one will be the BIM in infrastructure lifecycle. So studies shows that BIM is being used worldwide for lifecycle management, though Malaysia remain limited to pre-construction phases. Second, maintenance challenges in waste infrastructure. Okay, most facilities use outdated methods with no real-time monitoring or predictive strategies. Third, barriers to BIM. The most common include technical limitation, funding shortage, and also organization resistance and policy alignment. Fourth, BIM for sustainability. BIM helps with the carbon tracking, resource use, and green infrastructure when integrated with IoT or GIS. And lastly, the research gap, which most prior studies focus on building rather than waste infrastructure or post-construction operation and management phases, and especially in Malaysia context. Alright, this research applies a 6-phase mixed method methodology. For the phase 1, we can see for research design, it is to establish the objective, the scope, and the questions. As for phase 2, we will move on to the literature review to identify global trend, local gaps, and thematic categories. As for phase 3, data mapping, where stakeholders are identified using purposive and snowball sampling. Tools such as interview guides and also surveys as are aligned to objective. So as for the objective, we will go. I will conduct a HP questionnaire forms. Okay, as we go for phase 4, data collection. So we will conduct qualitative interviews, capture expert insight, while quantitative surveys on AHP validate broader patterns. Okay, on phase 5, data analysis. Manual thematic coding is applied to quality data. Description statistics are used for such survey responses, and the HP or analytic hierarchy process is used to rank and identify critical barriers. Okay, triangulation ensures the data is credible and balanced. Therefore, we move on to the phase 6, which is the most important part, which is the framework development. Insights are synthesized into a conceptual B model, reviewed by experts and documented for use by authorities. All right, so let's have a look to my plan Gantt chart on the work plan that shows the project timeline from week 1 to week 42. As we can see on phase 1 and 2 run from weeks 1 to 20, and also from phase 3 spans weeks 19 to 25. I proceed for the next semester for phase 4 is from week 25 to 31, and for the remaining are from week 31 until the end of the semester, which is week 42. So lastly, the expected outcome include 1, a complete picture of current operation and maintenance practices and digital limitation. 2, identification and classification of technical, financial, organizational, and regulatory barriers. 3, a scalable conceptual framework to support BIM interaction in public sector maintenance. And 4, a contribution to Malaysia's transition towards IR 4.0, smart cities, and the SDGs. Alright, to conclude, this study addresses a pressing issue, the modernization of public waste infrastructure through data-driven tools by understanding current practice and barriers. This project offers a practical, forward-thinking framework that not only helps stakeholders transform maintenance system, but also support our national goals for sustainable, circular, and smart infrastructure. And therefore, thank you for your attention. I now welcome for any question from the panel. That's all from me. Thank you.